Gear and Gear Unit Design Module 7, Introduction to Involute Gear Tooth Correction, and this is the second lecture on Involute Spur Gear Tooth Correction. Now, in this lecture I shall cover concept of Involute Gear Tooth Correction, then amount of profile shift, that is the tooth correction, recommendation on amount of profile shift, minimum number of teeth at different operating condition, characteristics of corrected gears, effect of amount of profile shift on tooth shape, undercut etc., and finally, forms of tooth, undercut etc. Now, already I have discussed how the gear correction is given. I have also stated that what condition gear corrections are provided. To make the gear and pinion of equal strength, correction is provided. To make the center distance a square value, the correction is provided. But mostly when the teeth number is small, in case of pinion where there will be undercut, to avoid that undercut, teeth correction is essential. Now, the amount of teeth correction, as I told, say this is the rack cutter, the in blue lines, that is the rack cutter. Initially the rack cutter pitch axis was passing through the standard pitch circle of the gear which is being cut. Now, what we have done? We have withdrawn the gear up to an amount by delta. This means that the cutter is not being allowed to go full depth, and we are finishing the cutting process there itself. So, that is by the pink line, pitch line. Now, when we are finding the contact situation, we consider that from that point the height of the rack is one module which is standard. So, in this case, as if it is not a cutter, it is a basic rack, and we can go up to the point where the corner will touch the intersection of or point of tangency of the line of action and the tooth profile of a teeth. So, this is the limit. Now, the amount of shift delta is equal to plus minus x m. Plus is for plus correction, that means when we are not allowing the cutter to go to the full depth of cut, that is called plus correction. This means that in case of external tooth, the center distance of the cutter and the gear is being cut will be more by the delta amount. For that, this is plus. Definitely the tooth, final cut tooth will of more width, and if it is a minus sign, then it will given the extra amount of cut, extra amount of depth by delta, which is x m. In this case, in this figure, it is shown as if it is withdrawn, because we are trying to find out how much correction is needed for a teeth which needs the correction, where the number is less than critical number. Now, S0 means no change in center distance. Again we should keep in mind that this is, we are giving the corrections in such a way that there will be no change in center distance, then we call this is S0 gear, but actually there is no meaning when it is not meeting with the gear for which it is designed. And if S means their center distance change is possible. This is we need to follow, because if we give S0 correction, S0 gear correction, if we mean it, that means there is no change in center distance. Therefore, if we give plus correction to the pinion, we have to give minus correction to the gear and vice versa. In case of center distance change, if we call S corrections, that might be anything, pinion is corrected, gear is not, both gear and pinion corrected, both given plus correction, both given minus corrections, etc., etc. Now, in this case what we have, I have shown the dark blue line, that is the increase in tooth height. This is from the pitch line, this height is AFC into module, this is from this point, that is addendum factor of the cutter into module, addendum factor of the cutter will be 1.25. So, this means that even if in withdrawn condition the cutter, the extra amount which is clearance amount, that may go inside the base circle at the first point of contact. This will give only root, and that profile is non-functioning profile. Okay. Now, next what we have shown, that if we give the minus correction, then it will go, it is given by a red line, it will minus correction means the x m is equal to delta is equal to minus x m, but in this case we have given the positive correction. So, again by the pink line the cutter will come to this position. Now, again these red line and the pink line, that is shown the height is shown 1 module, height is shown 1 module, the extra amount clearance, this part is not added to the cutter, that is just to understand that where it is touching. So, with this concept we are now giving plus correction. So, therefore, the tooth thickness will increase, which is shown in this figure. The dotted line is the new teeth profile and this shift is delta. Now, the plus sign is the plus correction outward shift of the cutter. This means that in case of external tooth, the cutter is not fed to its full depth, which already I have mentioned. In case of internal gear, it is vice versa. This means that if we give the plus correction, actually as in case of internal depth is internal gear, the teeth is the gap of the actual number, same number of external gear teeth, and the gap is the teeth in case of internal gear. Now, what we are doing, definitely the cutter is inside and we are increasing the center distance. Increasing center distance mean positive corrections, and for that it is going further, it is cutting the internal gear to the further depth. So, that we should keep in mind. Of course, it can be taken in otherwise also, only we have to remember the sign convention. Now, let us come to the geometry. PQ is the portion, this is originally base circle, this is P is the original pitch point. So, we can write sin alpha is equal to PQ divided by PT, that is PQ divided by PT. This is the standard pressure angle alpha. Now, what is there, as we are considering this is the point of tangency with this Carter's one module height teeth. This is, we are not considering the additional amount, clearance amount. So, for that this amount must be m minus x m, this portion, because we have shifted by x m, and after that this height up to the this blue line, this height is can be defined by module minus x m, because for the standard rack the addendum height should be one module and that divided by P t, but again P t must be equal to R p sin alpha, whereas R p is the pitch circle radius of the standard gear being cut. So, we can write m into 1 minus x must be equal to R p is equal to m z by 2, that is the number of teeth into module divided by 2. We are still considering straight tooth spur gear, and if we put this is by 2, this is becoming sin square alpha. P t we put here R p sin alpha, and this is another sin alpha is coming for that. So, this will be m z by 2 sin square alpha, because this sin alpha is there. So, we can write 1 minus x is equal to, x is the factor for teeth correction or shift, is equal to number of teeth divided by 2 by sin square alpha. Now, we write 1 minus x is equal to z by z mean. This is, if you remember, that 2 by sin square alpha is equal to the minimum number of teeth up to which there will be no undercut. Okay. So, that we have defined as a z mean. So, we can write 1 minus x is equal to z by z mean. What is z? That number of teeth we are going to cut. Okay. So, depending on number of teeth, suppose this is 17 in case of 20-degree teeth, suppose we have taken 18. So, 18 means we will find that x will be some minus value, that means it can be given further depth of cut. Suppose this is 14, then you will find x is positive, that means we have to give the positive correction. Okay. Now, this z mean is equal to z c, that critical number of teeth which we have already defined, which is given by twice into addendum factor into sin square alpha. Now, this addendum factor I have mentioned, because if the cutter is having some different addendum factor, we can go for higher or lower amount of corrections, but for this purpose during this course we may consider addendum factor is equal to 1. This will be easy to consider, and 2 by sin square alpha for 20-degree it will be slightly more than 17, and we consider the z c is equal to 17. Now, this is, so we can write itself z mean must be equal to twice by sin square alpha. Now, considering 1 minus x is equal to z by z mean, we can find out, we can calculate the x is equal to z mean minus z divided by z mean, that means minimum z. Ideally, which is equal to the critical number of teeth twice by sin square alpha in case of 20 degree in case of involute gear with addendum factor is equal to 1. Now, in practice z can be taken less than that calculated by the equation of 2 by sin square alpha, that is which is critical, ignoring the minor deviation in tooth profile near the root. Now, one can say that if we keep the tooth profile not non-involute at the root, and if the tooth comes in contact there, then definitely it will violate the laws of gearing. Here it can be mentioned that with the tooth deformations already laws are violated to some extent. So, if there is minor deviation, that may not be harmful, and by that process we can go for minimum number of teeth, and with that size optimization can be done. So, there are some recommendation. Now, for an example, in case of 20 degree involute, Z mean or ZC is calculated 17, it is actually 17.097. Now, in practice, let us consider this nomenclature, we put Z minimum P, that is for practice. We can take this is 14, sorry, we can take this is 12 for slow speed application, we can take 12 for slow speed application. Mind it, we normally supposed to take 17 number of teeth, whereas it is recommended that without correction, even if we can go for 12 teeth, if the speed is very slow, then it is recommended as 14, this number can be taken 14 for medium speed application. Whereas, if we go for high speed, then it is better to go for 18, not even 17, we should go for 18. So, that there would be less dynamics. This means that the violation of conjugacy can be accepted for slow speed or medium speed. Now, let us see what will be the teeth number or correction factor. Therefore, factor x is now expressed as in practice Z minimum practice minus Z divided by Z minimum. This Z minimum is in case of involute 20 degree will be 17. That means, this Z mean we have to calculate using ZC is equal to twice by sin square alpha, whereas Z mean P will be the number recommended for the practical application. Now, example, if we take an example, we will understand in better way. Let Z be 13, we have taken 13 teeth number and 20 degree pressure angle, and it is of slow speed application. Then the correction according to the formula, this is becoming 12 minus 13 by 17, which is minus 0.0588, close to 0.06. That means, we can give this much of minus correction, that means, we can further deepen the cutter and allow the undercut. Now, this minus sign indicates that more depth of cut is given, but how it will work? As I told, there will be no harm, although it is not necessary to give these minus corrections, but it is shown that even minus correction can be given. Now, let us consider the same 13 number teeth we are using for high speed application. In that case, we need to go for a correction of amount 0.294, nearly plus 0.3, the half of the negative correction for slow speed what we found, that is numerical value, but no meaning. So, this is quite interesting that for high speed, low speed we can go for different amount of corrections of the teeth. Normal practice, the in industrial gearboxes 13 tooth number below 17 in case of 20 degree involute is not used, if it is straight tooth spar gear at all. If it is helical gear, then we can perhaps go for 15, 14, 15, because there the amount of correction, to calculate the amount of corrections, although it will be complicated, but we can roughly say we have to consider then the formative number of teeth, which is z divided by cos cube of helix angle. So, that means for 13 teeth, suppose if we take the 15 degree, probably it will come close to 17. Okay. But there the amount of calculating the correction factor is different, because it is in the transverse plane. So, sorry, other plane. Now, if we consider the characteristics, what are the characteristics of corrected gear? First of all, this is avoidance of undercutting. This is the first character of the corrected gear. Corrected means in this case profile shift, not the profile correction. Attainment of predetermined modified center distance. So, suppose the center distance is not multiple of 5 or multiple of 10, we would like to bring to that value. So, we can provide the corrections to increase root and flank strength of teeth, betterment of sliding and contact relations, because if we go for the positive corrections, in that case contact will be at higher, the if we consider the cylindrical part of the profile, it will have higher radius of curvature. So, definitely this will be better. Then to shift the beginning of effective profile away from the base circle, you see this contact very close to the base circle is not desired, because there the gear where the it is touching at the root, it is having practically 0 radius of curvature. So, from contact stress point of view, it is not good. With the gear correction both types, that means if we go for profile shift or profile modified, we should remember the base circle does not change, it will never change. Therefore, all calculations can still be referred to the base circle. Also, the circular pitch at standard pitch circle remains same, although the thickness of the corrected tooth at standard pitch circle is different from its standard value, which is pi m by 2. The root thickness of standard gear at pitch circle is pi m by 2. So, that will remain same. Now, let us observe what happens if the correction is given. So, effect of amount of correction on involute spar gear teeth. So, we have taken a teeth here, it is the tooth number is 17, we have taken 17 number of teeth, and then we have provided different amount of correction. Now, as it is told, the 17 number of teeth actually do not need any corrections, although for high speed it is better to go for at least 18 straight tooth spar gear, or in case of roughly we can estimate that in case of helical gear, the formative number of teeth should be 18 at least. However, we have shown here considering a teeth number 17 and 20 degree involute, that is the minimum number of teeth. If we give plus 1 correction, then tooth will become like this. One thing to be observed, the tip is almost it is pointed. So, we will discuss later, there is certain limit, we cannot go for any amount of correction for any number of teeth. Now, if it is given no corrections, then tooth profile is something like this. And if it is given plus not 5, it is, as you see, shape wise it is better than, you can see it has more widened tooth, as well as tip is also is having substantial amount. So, probably on 17 teeth we can go for 0.5 corrections and to have better form of teeth. However, if it is given minus not 0.5, then as you see that the root has become, there is a undercut, this is undercut, so this is undercut, and as you see that this portion is not useful, also the root has become very weak. So, definitely we would not go for minus 0.5 correction in case of 17 teeth. So, this is just to show what will be the form of teeth. Now, again what we have taken, we have considered different number of teeth and we have given different amount of correction there, just to have a what the forms become after correction. Say if we take 10 number of teeth with 20 degree involute and without correction, so this is the shape, clearly there is an undercut and this section is weak. Okay. Now, if we provide a 0.5 corrections which can be calculated, we can take, say, depending on the speed we can calculate how much correction we can give. So, let us consider it is for high speed, then we will put 18 minus 10 divided by 17. So, it is almost close to 0.5. So, if we give 0.5 correction, then this will be the shape, and it is, you can say this base circle is here, whereas this root has become above the base circle, and this has, this is called trochoid, this trochoid is having the proper shape, root is not that weak, as well as considerable tip is there also. Of course, this with the positive corrections, tip is also increased to keep the height same as 1 plus 1.25 module. So, it can be increased, we can truncate of course, but this is definitely acceptable. Now, let us consider another set of teeth which we have taken, z is equal to 14 and there is no correction. Now, apparently this tooth can be used, of course, not for the high speed, but for medium speed definitely z 14 and or slow speed no correction can be used. Okay. But still if we give the correction of 0.5, the tooth form is very good, tooth form is better than the same amount of correction with 10 teeth, and also tip is there, substantial amount teeth is there, root is stronger. So, definitely this will be a good choice to give 0.5 correction. If we go for 17 number of teeth, in that case this is obviously acceptable, but if we give correction, definitely there will be a improvement, root improvement. If we go for 20 teeth, then what we find that this teeth is far better than 17, 14 etc., without any corrections, and definitely that is accepted. So, for this lecture I have followed different sources, but mostly I have followed G. M. Moitro's book. So, I acknowledge very much that he has written the gear correction in very concise form. I have also consulted Dean and Indian Standard. So, this is just an extract to give you an idea what is the correction, how to calculate the amount of corrections, etc. But this subject, this area is you need to study more to where the correction is given, where not, and how it is calculated, particularly in the manufacturing. Manufacturing, of course, the manufacturer they recommend you, if you set automatically you will get that amount of corrections, but there are many things which we need to follow if we go for helical gear, bevel gear and other gears. But this is only the basic idea that how the amount of correction is calculated. Thank you.